Okay. 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 Okay, so welcome to the class. We continue statistics. Some students were a little confused regarding dependent and independent variables. So let's look at it first. Okay. Just a second. Independent and dependent. Okay. Independent and dependent variable. In statistics, we often try to find some relationship between variables. What is a variable? Variable could be anything. Variable is some number. Okay, variable, how much ice cream you eat, how many times you go to the toilet, how many hours you sleep. Variable is any number. Okay, it's variable, it varies. You can sleep 10 hours, you can sleep 6 hours, you can go to the toilet 2 times per day, you can go to the toilet 10 times per day, right? Variable is some number. Variable, and it's called variable because it varies. Okay, and statistics tries to find answers to the questions, and how two things are connected together. So some variables are independent. Okay, so let's say independent variable, how many cups of water I drink. Okay, so cups of water. I want to drink 1 cup of water, or I want to drink 3 cups. It depends on my mood. I can drink any number of cups, but then it will cause what? Toilet, right? How many times I go to the toilet? Times to toilet, right? Remember we were studying causation, right? Okay, just a second. Right? We are in statistics, we are trying to establish correlation and causation, right? How one variable will have effect on another, right? And there's a positive correlation, right? I drink 1 cup of water, maybe I go to the toilet 1 time. I drink 2 cups, I go 4 times. I drink 6 cups, I go 10 times, right? Very easy with that, right? And you might say, of course, everyone knows about water and toilet, right? But what about smoking and cancer? Can we prove that smoking has cancer? Because some people smoke and don't have cancer. Other people don't smoke and have cancer, right? So, and third, smoke and have cancer. So we need to look at everything, and not just in one person, not in 10, but maybe thousands of people, and see some relationship between variables. So who says what is independent and what is dependent, right? Before we do any statistical analysis, we have hypothesis, right? We have some idea. So we say, okay, cigarette and cancer, right? And it's easy. Cancer cannot cause cigarettes, but cigarettes can cause cancer. So this is, we decide what variable will be independent, what variable will be dependent. You know, we can study anything and then find some secret, not secret, but unseen relationship, right? For example, if you go to the gasoline station, take a cup of gasoline and drink it, you will maybe die immediately. This is easy to understand, right? You cannot drink gasoline. Gasoline is very bad for health. But cigarettes, it's not so clear, right? You smoke one cigarette, you will not die. You can smoke for a whole week or a month, maybe you will not feel anything bad to your health. But if you smoke for many years, will it have some effect? Same thing if you drink cola, Pepsi, you know, one time, two times, you know, nothing will happen. But if you drink for many months, a year, many years, will it have some effect or not? For this, we need to look at many people and then compare, right? Again, not everyone will be affected, and this is probability. But so far, this is variable. So anyone who still doesn't understand that, please let me know. Okay, so I assume everyone now understands variables. Variable is some number, right? So cigarette is not a variable. Water is not a variable, but cups of water, right? Some number. We need some number. Cigarette, right? How many cigarettes you smoke, how many days, how many years. Times you go to the toilet, 1, 2, 3, 4. And cancer, how many people have cancer? So variable should be a number. Okay. And then, okay, next thing, correlation. Correlation. Okay, just a second. Another one. Okay, correlation, regression. Regression and causation. In go to the next cause. In moment. In everyday conversation, we often use this word, cause and effect. Right? Cause and effect. You drink too much water, you will go to the toilet, right? You try to hit the dog will bite you. You touch the fire, you will burn, right? Cause and effect. So, for example, touch fire, touch something hot, touch fire. burn, right? It's very easy. Cause and effect. Effect will always have a cause. Cause, you do something and you will have effect. Like if you study for the exam, effect is good grade. If you miss the class, you don't read the book, you don't listen to the lecture, effect, bad grade. Cause and effect. Okay? Cause and effect. But in statistics, we don't use it as freely as in everyday conversation. First, we talk about correlation. Correlation is, okay, so just a second. Cause and effect. So in a statistical term, we could say independent and dependent variable, right? Touch the fire. For 1 second, nothing will happen. But if you put your hand and hold over the fire 5 seconds, you will have a burn, moderate burn. If you hold your hand over the fire for 10 seconds, it will have more severe burn, right? So cause and effect, independent and dependent variables. So correlation, imagine we have x, y, so x here, y here, xy axis, and we put here, okay, we put here seconds of holding your hand over fire. 1 second, 2 seconds, 3, 4, 5, 6, and here we put severity of the burn degree, right? Burn could be 1st degree, 3rd degree. So it goes in reverse. So not like nothing, 3rd degree, 2nd degree, 1st degree burn, right? And then we do some experiment, right? How we find information for statistics. We can do observation. We can do survey, right? Ask questions. Or we can do experiment, right? And then we look at numbers. Okay, and if you do it one time, it has no significance. Maybe it's a mistake, maybe something else. Okay, just a second. Okay, just a second. I need to do it for myself.
Oh, teacher, I'm
Yes.
sorry.
Yes.
I couldn't see the attendance number today.
I put it in the message. You can look at general in the group. I put it.
Okay, thank you.
Okay, so again, when we deal with statistics, if you say, "Oh, I did it," I one case is nothing. We need many, results. So okay, we did many experiments, and when people held their hand over the fire for 1 second, mostly nothing happened, right? No burn. And then like, I don't know, 3 seconds was 3rd degree. This is like somebody had nothing, somebody had this, and then so this is the results, right? Each dot is each experiment. Okay, so now correlation is correlation, right? Look at the word correlation. So something correlates, something goes together, right? We can see, and we can see it's a positive relationship, positive linear, right? It's a line. We can draw a line, and it goes together. The more you hold the hand over the fire, the more severe burn you have. So it's a positive, positive linear, right? You can put a line, linear relationship. Sometimes it's negative, right? Negative. The more you smoke, the shorter your life is, right? It's negative. The more you smoke, the shorter your life. It's not moving together, it's moving in opposite directions, right? Okay, regression. Okay, let's look here. Just a second. Okay, so regression. Regression, it shows us the strength of the relationship, right? So okay, we put a line, but how strong is it connected, right? Strength of the relationship. Like each second over the fire increases the burn by 5%, right? Or by 20%, or by a million percent, right? It shows us how much increase in this will increase in that. So for example, let's say the hours you study for the final exam, 1 hour a week, 2 hours, 3 hours, 4 hours, 5 hours, and then the grade, right? So let's say this is F, right? D, C, B, A. We want to know the strength of the relationship. So what? Each hour will increase your grade by 1 letter, or by half a letter, right? So we are trying to find the strength of the relationship. Let's say every 3 hours will increase it, right? Maybe like that. Strength of the relationship, okay. So regression, describe how an independent variable is associated, right? The strength of the relationship, they can measure it. Some things are connected, but very weakly. For example, yes, you need to do a lot of this to get a little bit of that, right? You need to study 10 hours to get a little bit increase. But it's like the strength of medicine, right? You have a headache. How many pills you need to take to stop that headache? If you take 1 pill and it immediately goes down, right? So strong relationship, strong medicine. Other pills, you need to take 10 and it's not moving at all, right? So regression shows strength of the relationship. Correlation just shows that there is a relationship. Okay. Okay, so just a second. In regression, we measure the relationship between, how much is it moving, and then we can say there is a strong relationship, weak relationship. Okay, so let's see. Uh, in this example, example C, no relationship, right? So dots are positioned, without any order. This is A, strong positive relationship, right? It goes like a straight line. B is strong negative relationship. And D, you see it's curved. It goes, but it's slow, it's not moving. When you have a straight line, it's going faster up, and it's not going up as fast, right? It's taking off. Imagine you are flying an airplane, right? Inside an airplane. Usually when you fly on commercial airlines, it goes like this, right? So people feel comfortable. So it goes longer in horizontal direction, but not as fast in vertical, right? So people feel comfortable. But a rocket goes like this, right? Vertical and horizontal are together, so it's faster, but if you would sit inside, it would be very uncomfortable, very rapid, right? So here it's going up slower than it's going further, right? So if you studied math, rise over run, so this is the formula, different relationship. So here in A, we have stronger regression, again, medicine, right? You take one pill and immediately your headache stops. And here it takes longer, so it's not as strong. So there's formulas. I don't require you to understand the formulas. I want you to just understand the concept. Okay. And when we have correlation, okay, and then we understand what type of regression it is, we can talk about causation, right? So in statistics, we don't immediately talk about causation. We need to wait, measure everything, and then we can say what kind of relationship. Strong, okay, like strong, okay, strong, weak, or no relationship, right? Positive and or negative. Strong relationship, strong positive, strong negative, weak positive, weak negative, no relationship, no observable, right? We did experiments, we don't see any relationship, right? So, just a second. Hypothesis, okay. In statistics, before we do research, we need to have some kind of idea what we want to study. Very few scientists just sit and suddenly they have some idea. Mostly now scientists have hypotheses. Okay? They have hypotheses about what they want to study. They think, maybe there's a relationship between how many, okay, so like let's say garlic. We want to find the relationship between garlic, consumption of garlic, and blood pressure. maybe there's something with, garlic and blood pressure. So, just a second. Hypothesis. Just a second. Okay, so just a second, I copy this. Just a second. So we are trying to find relationship between garlic and blood pressure, right? So there could be three possible, no relationship, strong, positive, or weak, right? Effect of garlic on blood pressure. So nothing happens. Strong relationship and weak. And it could be strong both ways. Garlic could increase your blood pressure or lower your blood pressure. And weak, again, weakly, it could be weak, right? Lowering or raising your blood pressure. So we have some hypothesis. Null hypothesis is there's no statistical significance, right? No statistical significance. It's like, it's so small that it means nothing, right? Oh, one person, in one person it changed something, but overall nothing happened, no statistical significance, right? So we have null hypothesis and we have alternative hypothesis. Okay, it's H0 or H. So this is H0, H small 0, and we have alternative hypothesis, H1, right? So if H0 is correct, there's no relationship, but H1 is alternative hypothesis. It's something, it has, something is happening. So this is how it works. It's a little complicated to think like this. We don't think of things like this in everyday life, but scientists think like this, and it helps them, right? So you have some hypothesis. So null hypothesis is there's no relationship, and alternative is there's some relationship. Garlic has some effect on blood pressure. Okay, next is probability. Okay, so moment, population versus sample, this one. Population, I already told you this, but I want to make sure that you understand it because it will be on your exam. So you need to be really clear about these things. So population. Population could be anything. Could be all the people of Thailand. Could be, for example, we want to know what Thai people think about China. We want, or population could be all students at Rajabhat University, or it could be all the people who smoke, or all the women, or all the little girls, whatever. Population, right? All, so we have some population, right? Smokers or non-smokers. Let's say population is Thailand, all the people of Thailand. Population, right? Population example, all Thai people, right? And if I say all Thai people, right? Um, Again, who can have opinion, right? We don't care about children, right? We care about all adult, right? All adult Thai people. And so this is from, let's say, 18 to 90 years old, male and female, right? So people over 18 to 90, male and female, and they live in big cities, they live in small cities. Some have a lot of money, some are poor, some have a lot of education, others have no education. So it's everyone, right? Everyone. So we want to ask them, what do they think about situation in Ukraine, right? So do you support Ukraine or do you support Russia? It's interesting to know what they think. We cannot go and ask everyone, right? It's impossible. How? Because there's millions of people. It would take so much time to ask everyone that it's expensive and it would take a lot of time. It's impossible. Okay? Please understand. It's even if you have a lot of money, no one wants to do that. It's a waste of resources, right? It's not necessary. It's like we have tools, right? For example, when you cook, you have a tool, you have oven, right? A stove, and it can help you to cook. Okay, you can go and get wood and burn wood and cook, but it would take more time, right? Washing clothes, you can wash your clothes by hands, but it would take more time. You have a washing machine, right? Tools, we have tools. So in statistics, we have tools. So we create sample of your population. There's a special formula to find out how many people you need. Let's say your population is, I don't know, 60 million. Example, your population, this adult Thai people from 18 to 90, 60 million. There's a special formula that will help you find what your sample should be. Maybe 1,000 people is enough. You just need 1,000 people, okay? Again, I will not show you the formula, but just believe me, okay? 1,000 people, okay, just a second. Just a second. So 1,000 people, we just need 1,000 people. Oh, great, we'll just go to Bangkok, we'll find 1,000 people in the coffee shop. And no, it doesn't work like this. Your sample should be this word, representative. Your sample should be representative. It should represent your population. So if you go to Bangkok and take 1,000 people who are sitting in coffee shops, it doesn't represent Thailand, because look, people who live in Bangkok, they are different, right? Mostly they have education, mostly they have more money, right? And you'll say, so what? So they're reading more news, right? Maybe they're reading news, they have money, so their answers will be different from people who have no education, who are just watching TV once a day in the night, right? So you will have incorrect sample. Sample is like a drop, right? You go to the sea is salty. How do you know it? You put your finger, you mix water. Oh, it's salty, right? Right? So we need to, like when you cook soup, you mix, and then you take a sample. Same thing here. We need to take samples from different places in Thailand, from maybe every city. Again, in Thailand, let's say male to female, maybe there's like, let's say 55% female in the country and 45 male from in. So our sample should be the same, 45 male, 55 female. So it looks like a miniature version of the country. And it should be random. What is random? We should find random people and ask them. We cannot go to the coffee shop, because in the coffee shop, a certain group of people gets together, right? People who have money, right? So they don't need to go to work. They're sitting in the coffee shop. No, it should be random, like stopping people on the street, stopping people at 7-Eleven, but not just 7-Eleven, right? At Tesco and 7-Eleven and Rimping, right? Random, a little bit here, a little bit there. We cannot stop only beautiful girls, or we cannot stop only old men. It should be random, like every second person who comes to the shop, we stop them, right? So it's random. 1,000 people, right? 1,000 people from every city, from every location, every age, right? So this is our sample. Okay, we have 1,000 people. So now we can do it, right? We can ask them questions. When we ask them questions, we cannot say, we need to be very careful how we ask the question. We cannot say, do you like what do you think about the fact that Russia kills people in Ukraine, right? You cannot ask questions like this, because your question is already loaded with opinion, right? Russia is killing people. So your question should be very open. What do you think? Okay, like this. Do you follow the events in Ukraine? Yes or no? What do you think about this event? Whose side are you on? Uh, what should Thailand do? Should Thailand be neutral, or should Thailand be on this side or that side, right? You should not help people. You should be, like example, if you go and you wear a Ukrainian flag on your t-shirt and you ask questions, of course they know that you're pro-Ukraine, so you're like against Russia, right? Or again, another one, you'll say, hello, I'm from Russia, I'm asking questions. Again, you cannot do this. You need to be very neutral. You should not help your sample, right? So they express their opinion. You're interested in their opinion, okay? So you collect answers and then you will see, right? And this is okay. We will do. You remember? Just a second. Descriptive versus inferential statistics. So in my example with the Ukraine and Russia, we will have descriptive statistics, right? We will describe the situation. It will say 85% of people said yes, we follow the events. Out of this, like 30% said that, 70% said this. Also, it's interesting that men were mostly for Russia, women were mostly for Ukraine, old people were mostly for this, younger people were mostly for that. Also, people with education, no education said this. So it's interesting how how things are different inside a group, right? So people who have more education, they read more news. If they speak other languages, they can listen to BBC, versus when people have no education, they rely only on Thai news. It's all different, right? Inferential statistics, again, is, okay, just a second. Inferential statistics, we're trying to find some relationship, right? So we collected data and then we decided, look, people who had education, they were, this, and people who have no education, they had a different opinion, right? So there's maybe maybe there is some something to that. Maybe if people have education, they know other languages, right? And then it affects what they think about the story, right? Maybe we were also asking questions about languages, what languages? And then we can look, oh, if person knows some foreign language well, his opinion is changing, right? We're trying to find relationship. In inferential statistics, we're trying to find a relationship between independent and dependent. So in our case, independent is language ability, right? What languages do you speak? English. How well? Oh, I think I'm intermediate. And I speak English and French. And what is the level? So we collect all that information. And dependent is, what do you think about the situation in Ukraine? Whose side are you on? Or what news are you following? Right? And then we'll see that people who speak more languages, or people who speak at least 2 languages with high ability, they're able to watch the news, and then they will be more, because what I mean is, if you only speak Thai language, you can only watch Thai TV. Thai TV is coming from Thai government mostly, right? It will have Thai government point of view. Thai government is neutral or pro-Russia, so you will be pro-Russian. If you speak other languages and you can watch foreign TV or you can watch foreign websites, they're mostly pro-Ukrainian. So these people will be pro-Ukrainian. So younger people, and this is true, younger people, okay, so, okay. This is the news. This is the news I saw. In Thailand, the war in Ukraine divides the generations, right? So if you read the article, they're saying older people are pro-Russia and younger people are pro-Ukraine. Why? My explanation is simple. Again, I don't know these people. I cannot go and ask everyone, but I think because younger people read foreign news, watch foreign news, they're on Facebook, and Facebook has information from foreign websites, they will be pro-Ukrainian. Older generations, mostly they don't speak foreign languages, so they are relying more on Thai media. Okay, so again, this is my hypothesis, right? I don't know everyone, right? I don't know 1,000 people to do my research. This is my previous experience. Okay, maybe my hypothesis is right, maybe it's wrong. We need to do more research to have correct answers. Okay. When you do your sample, okay, you can study your sample. Your sample will have mean, right? Average number. And your population also has mean. They should be the same, right? And how will you know that? Well, there were experiments done. If your sample is representative, if it's random, the mean should be more or less the same. Okay? So that says that. Just a second. Just a moment. Okay, then okay, so far, do you have any questions? Is there anything unclear before I continue? Okay. So again, population is the entire group that you want to draw conclusions about. We want to have conclusions about the country of Thailand, what they think about the situation in Ukraine. But we cannot go and ask everyone. It's impossible. So you're going and somebody says, excuse me, we're doing a survey. Could you answer a few questions? He's like, okay. Okay. How old are you? Okay. And you live in here in Chiang Mai. Okay. And what education do you have? Okay. And do you speak other languages? Okay. Yes, no. How well do you speak French? Okay. Do you get the news from other websites, from foreign media? Okay. This is all independent. Age, education, languages. Okay, okay. But you don't tell them. Okay. And now, questions. Are you following the events in Ukraine? In Ukraine, okay. Uh, whose side are you on in the conflict? Okay. Do you think Thai government should be pro-Ukrainian, pro-Russian, or neutral? Okay. Like Okay, that's it. You ask just a few questions, people are not tired, they're happy to answer, right? This is your sample, some answers from the sample. Okay. Um, so it's practical, right? 1,000 people, we can stop 1,000 people, right? We have some employees and they can go and each one will ask 20 people on the street, and it's not expensive. Okay. Um, there's such a thing as sampling error. Just a second. Sampling error is the difference between population parameter and sample statistic, right? Maybe in the whole population, the average is 20, but our average in the sample is a little different. Why? In your study, the sampling error is the difference between the mean of your sample and the true mean, right? There's some error. Why? Because maybe by some chance, all the people we were able to stop were younger, or were on that day it was raining, so all young people stayed at home and old people went shopping, you know? Sampling errors happen even when you use a randomly selected sample. This is because random samples are not identical to the population, right? We're trying to be as close to the population as possible, but it still can happen. Because the aim of the scientific research is to generalize findings from sample to the population, you want the sampling error to be low by increasing sample size. Okay. The more the sample is, the better. Let's say it depends on the budget. Let's say we have the budget for only 300 people. The error will be larger, right? 300 people, uh, it's maybe they will all be people who are working on that day, or all those who are outside today, or mostly people who want to talk to you, right? So the error will be larger if you have smaller size. The high, 1,000 is good. 1,500 is better, right? You will have, because, in the country of Thailand, there's different people, good people, bad people, people who don't drink, people who drink, don't smoke, smoke, right? So the more people you stop and ask, the more it will represent your country in reality. And then when after we get our results, we want to generalize, right? Generalize, right? We have results for 1,000 or 1,500 or 300, and then we generalize it to the whole country. We say Thai people want Thailand to be neutral. How do you know that? Well, we stopped 1,500 people. They told us mostly 85% said they want Thailand to remain neutral. So we think it's true about the whole country, right? So, example, 85% of the sample, our sample, and so then the population is the same. 85% say Thailand should be neutral, should not get involved, should stay out of that, should not be with Ukraine or Russia, should stay out, okay? Okay. Okay. Just a second. So this is just a second. Just a moment. So this is what I taught you today is it will be on your final. So please, if you're still confused about something, you need to like listen to me again in this video, or find other materials that explain that you like how they explain. Okay, and then okay, just a second. And then you remember, okay, just and then, moment. There's so many. Okay. Remember normal distribution, right? Normal distribution, also known as Gaussian distribution, is a probability distribution that is symmetric about the mean, showing that data near the mean are more frequent in occurrence than data from the mean. In graph form, it looks like a bell curve. Normal distribution is the most common type of distribution. It has two parameters, a mean and the standard deviation. Okay, so probability, how likely something is to happen. And there's a theory that explains the standard deviation. For example, just a second. Standard deviation, okay, probability. Okay. For example, cat tail length. Okay, so maybe we put 16 here, 18 centimeters, 9. Okay, so cattail length, and this is probability. And we look at cats. We look at cats. If we look at maybe only 5 cats, you go to a coffee shop with cats, it could be like this. It could be like this. It could be like this, because you only have 5 cats, right? It could, maybe they're all with short, maybe they're all with long, maybe they're all with whatever, right? It could be anything. But if you look at more than 30 cats, it will be probability, you know, it will always be like this. Cats with very long tails, there are very few in the world, very long. Cats with very short, you know, very few. Mostly, this is the mean, average, right? 16 centimeters. 68% of all the cats will be here, around that number, okay? Around 16. A little longer, maybe 17, maybe 15, but it will dance around that, okay? So because this is normal distribution in nature, right? In nature, everything is around average, right? You don't see very many tall people, just one or two. You don't see very many short people, right? Mostly people are around the same size, height, for example, right? Uh, it same applies to like intelligence, right? There are very, very few super, super smart people. There are very, very few super, super stupid. Mostly people are around average, right? What I mean, like how many words you can remember, how many um, words you can read per minute, right? It, it's like this in nature, right? Because or very strong people or very weak people. This is, it works like this, okay? So just a second. The normal distribution is a probability distribution. So the total area under the curve is 100%. So this is everyone in all the cats here, 100%. Short tail, long tail, normal tail, everyone is here. Okay? So this is your, so you will ask, is this the sample or the population? Same. Okay, so this is total population. Total population of cats. All the cats in the world. And this is your sample size. Sample size, 100 cats. But you'll say, wait a second, there's different cats. Okay, so total population of Persian cats, right? All the Persian cats in the world, and a sample size of Persian cats, 100. We only have 100 cats. And if we did everything correctly, population and the sample will be the same, right? 16 centimeters tail, okay? If we do everything correctly. Okay. Okay, so today you have your presentations, right? You have some data to present to me, right? Just a second. Just a moment. Hello, can you hear me? Can you hear me?
Yes.
Okay, so just a second, something